Welcome, my Algebros and Algebabes. This is Professor Algebro. We're coming into this home stretch. We're getting close to the end of term for some of my high school children. For some of my other children that are continuing, what we're going to do, we're talking about special cases. I'm not talking about being in the institution like Professor Algebro was at one time, you know what I'm saying? But we're going to talk about special cases when we deal with what we call polynomials. Now, we have something called difference of squares. Now, the origin of difference of squares is as follows. If I multiply these together, now, Algebros, Algebabes, please, we're going to take a little shortcut here. This is one of the only special cases where I have a quadratic, where I multiply two linear binomials and get a quadratic binomial. That's two terms, okay? Now, x times x is x squared. Now, this is what happens. Remember my little oi, the outer and inner? 5x and negative 5x becomes 0, so I don't even write it. But negative 5 times 5 is negative 25. Now, if you notice, difference of squares means you see this, it becomes that. Now, we're going to go backwards. So, look here to here. Now, Algebros and Algebabes, we're going to pause this, and I want you to figure out what goes beside the x's. Okay, now we're back. So, the only thing I have to do, perfect square, yes. Perfect square, yes. What's the square root of 81? 9, my children. Now, that's the first one. Let me give you a little bit harder one. Same deal. Is that a perfect square? Of course it is. 4x squared. The square root of 4x squared is 2x. What is the square root of 11? Oh, excuse me, 121. Professor Algebro's had a long day. Square root of 121 is 11. So, we have 2x plus 11, 2x minus 11. Now, let me talk to you about the next. It's called a perfect square trinomial. The best way to do this is not to use a single term, but to show it this way. Now, if I wanted to multiply this out, I could do this. And what would happen is when all is said and done, I got my first term, so these two, that's 4x squared, right? I got my outer term, so 2x times 3 is 6x. Do it again, I get the same thing. Now this is important. Then the last becomes that. So here is the key for this one. To get the middle term, 2 times 3 is 6, double it, you get 12. So this is going to be 4x squared plus 12x plus 9. Okay? Now, we can do the same thing with subtraction, only this time, watch closely, children, instead of it being pluses, it's minuses. So 2x times 2x is 4x squared. Now, remember my little trick here. I had 2 times 3, you get this. 2 times 3 gives me negative 6, right? Double it, I get negative 12x. And last but not least, negative 3 times negative 3 is positive 9. Now, I know we're pushing this a little bit too much, but I got one last thing to show you. I'm over 4, but we're good. All right? Now, we're going to go backwards. Professor Algebro had to do a little middle math there. Yeah, now here we go. Now, this is a perfect square trinomial. What I did is we want to make sure this is a perfect square and this is a perfect square. Is 16x squared a perfect square? Well, yes, it is. It's 4x. Okay? Now, is 25 a perfect square? It is. It's 5. Now, with that being in there, we say, is this 4x minus 5 squared? Well, first of all, remember my little trick. 5 times 4 is 20. 20 times 2 is 40. So, there you are. Now, long video. Sorry for taking any of your time, but listen, no matter where you go, math is there. Professor Algebro, we're out. Algebros, if you like what you saw, hit that like button and subscribe to our channel. Later.